can be considered as short circuit current. Okay, and we were going through this slide. Any questions from the previous class? I think we were discussing about this slide. Okay, okay, let's try to solve a problem at the very beginning, which will, okay. We have some curves here. Can you see the slide here?
Yes, sir.
Okay,
Yes.
and take your paper, pencil, and calculator ready, and so that we can solve the problem. What we have to do, we have to find the field factor. Actually, it should be meter square. Okay. We have couple of graphs here, couple of curves here for different irradiation from 600 watt per meter square to 1400 watt per meter square. So what we have to do, we have to find the field factor from this curve, 1000 watt per meter square. Okay, okay. Can you calculate the field factor from the following curves for the irradiation rate of 1000 watt per meter square? What's the definition of field factor?
The field factor is the maximum voltage and the maximum current to the by maximum open circuit current and maximum short circuit current. Open
Okay.
circuit and short circuit.
Okay, in that case, can you calculate the field factor for from the following curve? Okay, actually, I want all of you to solve this problem. I need to find the field factor because this kind of problem might appear in the exam. We know the definition of field factor. Field factor is nothing but the ratio of maximum power to power. So can we calculate the field factor from these curves for a particular irradiation of 1000 watt per meter square? Okay, I have explained the definition in the last class, as well as you can see the formula here. So what will be the, we have couple of irradiation rate of 600 watt per meter square to 1400, but we have to find the field factor for a particular data, which is 1000 watt per meter square. And we have uh, current versus voltage characteristics curve here. This is the voltage and this is the current curve. Okay, anyone has solved the problem by this time? Okay, Shubhan Iqbal, what's the value of the field factor? How can
Sir,
yes?
sorry, sir.
What is sorry, Shubhan Iqbal?
Sir, I can't, sir.
Okay, okay. Was it difficult to understand the definition of field factor?
স্যার কালকের ক্লাসটা ঠিক মতো বোঝা যায়নি স্যার।
Okay, what do you mean by বোঝা যায়নি? Were you present in the class, or were you
ইয়েস স্যার।
just turned? Did you just turn the? Uh, did you just log in the Google Meet and leave the place?
নো
Okay,
স্যার।
I think I have already. Okay, okay. What about others? Okay, what's the meaning of বোঝা যায়নি? Would you please explain? Actually,
Sir,
it might have different meanings in the
sir,
sense that
maybe we
now
are,
maybe my voice was not, or you did not understand the definition, or uh, okay, you might have other answers. What's the answer? Okay, Chuhan Howlader, can you
yes, sir.
yes, how to find the value of P max and P theoretical
Sir,
from
I'm not sure, but I think, sir, it depends on factors. Like when we use here the particles which construct the module and
no, no,
depends on
actually,
it.
okay, we have all the information here. To calculate the field factor for this particular incident irradiation rate, and which is 1000 watt per meter square. What's the maximum value, maximum power
The
for
maximum is 298.9
8.9? Okay,
watts.
P max. Okay, P max is already provided. You don't need to calculate I max or V max. It's already there, right?
Yes, sir.
To
Yes, sir.
98.9. What about PT?
Sir, PT we have to calculate, sir.
Yes, yes, we have to calculate from the graphs. So, but we know that the definition of PT is like this one. PT equals short circuit current, the product of short circuit current and open circuit voltage. What's the value of short circuit current? This is the value of short circuit current, right?
8, sir.
Okay. So what's the value of short circuit? What will be the value of short circuit current? Can you get any idea from this?
Sir, in the formula, sir, we can say that, sir, 0.85 minus
Sir,
0.95.
No, no,
it's maybe 8.4, sir. It's maybe 8.4.
8 point.
4, sir.
Okay, you can approximately say that because this is 9, right? 9 here.
8.5 we can say, sir.
So we can consider 8.4 approximately because it's lower than 8.5. So the value of his IC is 8.5.
Sir, we will take from the sir, we will take the value from the curve, sir. It will be approximately we will take, sir. Then, sir, the result will be vary, sir.
Okay. How? Okay.
Person to person, sir.
Okay.
The result will be vary.
Okay. Is there any other value of ISC?
Last class, sir, you told us the formula, sir. V maximum, sir. V maximum is equal to maximum power
Actually,
uh,
that is
0 point,
actually
sir.
yes, yes. Actually, that is not the formula. That is the variation of maximum voltage or maximum current. That means the peak value is approximately
Zero
like
point seven five to 0.9, sir.
yes, yes. That is yes. So which one will give you more accurate result? This one or the value. Actually, that was not the formula. Actually, that shows the variation of maximum voltage with respect to open circuits, and that is for different uh, manufacturers as well as for different irradiation rate. Okay, but in this case, the information of irradiation rate, which is 1000 watt per meter square. So for this particular data, what is the value of uh, current, short circuit current?
8.5.
Okay.
Okay, sir.
Okay. Someone has already mentioned that the value of current is 8.4. So Arman, what do you think? What will be the value if you want to
Sir, 8.3, sir.
8.3? Okay, 8.3. Okay. Okay. And what about others? What will be the value of short circuit current?
Sir, 8.5.
Yes, sir. 8.3, sir. Not 3.
3 or 4, sir.
Okay, it will be 8.4 or 8.3, whatever it is. So what will be the value of open circuit voltage here for this particular
45.
year?
45.
That means we have to calculate, we have to consider this one. The
Sir,
middle one.
45, sir.
Okay,
So
this one.
38.
How it can be 38?
Oh, sorry, sir. Sorry, sir. It's 45.
45, sir.
Actually, it's in between 40 and 50. So
Yes, sir.
approximately we can consider that it's 45. Okay, it might vary for different students. The value may not be, you can think that it's very close to 44.5 or 44. Okay, let's think that the value is 45. So is it possible for us to calculate the field factor now?
Yes, sir.
Yes, sir. Possible, sir.
We know the value of theoretical power. I mean the maximum the maximum power that we can get theoretically from the solar panel. It will be like this one, 8.4 times 45. So what will be the value of field factor? If you have calculator, can you help me to get that?
0.80.
79. 79, sir.
0.907. 0.70.
0.79, sir.
Okay, 0.79. Okay, who has mentioned 0.70? Which one is correct exactly? Okay, actually I
Sir,
haven't
I
calculated
divided
the
to
value.
98.9 divided by 378. That is 0.79.
Yes.
Okay, we already know the value of short circuit current and open circuit voltage. That means what we have to do, we have to multiply 8.4 by 445, and then we will divide 298.9 by the calculated value. So, okay, can anyone mention exactly what should be the value? Okay, someone mentioned the value as 0.79.
Sir, 0.80, sir.
Yes, sir. I have also get 0.80.
0.80. Okay. Okay,
Yes, sir.
approximately
Sir,
this is what.
we calculate, sir, the VOC open circuit, sir. Voltage for open circuit, sir. 8.3. That's why, sir, we get 0.80.
Okay, if you consider 8.3, it will be the value will be different. Okay, if you consider, okay, in that case, I have considered 8.4. So you should have mentioned 298.8 divided by 8.4. Okay, if we consider this one actually 8.4, then it will be 0.79. Okay, okay. This is the value. I think it's not that difficult to calculate the value. Okay, field factor. Just try to remember the definition of field factor, and it won't be that difficult for you to calculate the field factor. Okay, anyway, so we have seen from these curves that the maximum point depend on the weather condition. I mean, it's not fixed, because if
Sir,
the weather,
is that I have any unit for field factor, sir?
okay, what will be the unit of field factor? Okay, okay, let's try
There is
to.
no unit for factor.
There will be no unit for the field factor because it's the ratio of the same
Yes, sir.
quantity.
Same power, same quantity.
Okay.
Yes, sir.
So it's unitless. Okay, okay, and you can see from these two from the curves that we have here in this slide that in case of left one, the temperature is constant. I mean, the temperature is 25 degrees Celsius, but if the intensity of light, I mean, irradiance changes, then maximum power point vary. So it's not fixed. And from the right side, we can also see that if the rate is constant, and in this case, it's 1000 watt per meter square, then also maximum power point, which is like this one. These are the maximum power point. Also changes. I think the maximum power that we can generate or we can extract from the solar panel is not fixed. It's variable. I mean, it depends on the weather condition. So what we have to do here, okay, actually, so what we have to do, if we want to get maximum power, I think I have mentioned in the previous class that we have to, if we want to extract maximum power, what can we do here actually? If we operate the solar cells or the solar panels at different voltages, we will get less power from the solar panel.
Yes, sir.
So we should apply some external way so that we can get the maximum power from the solar panel. Suppose the irradiance rate is 1000 watt per meter square. In that case, the maximum power is like this one, 220 or 225 watt. And for that particular voltage, sorry, particular power, it will be like, if we operate the solar panel at this particular voltage, I mean, okay, at 27 voltage, at the voltage level of 27, we will get the maximum power. But if we operate the solar cell or solar panel at different voltage other than 27 volt, we won't get maximum power. That means the power that can be extracted from the solar panel will be different than the maximum power. So we have to apply some techniques, some approach, so that we can extract maximum power from the solar panel. And the method of extracting that maximum power from the solar panel is known as MPPT algorithm. Actually, MPPT is nothing but the short form of, short form of maximum power point track. It's like this one. Okay, wait a second. Maximum power point tracking. That means we have to apply special techniques to track that maximum power. That means the solar panel can can generate maximum, okay, 225 watt when the irradiance rate is 1 watt per meter square. And if we can operate the solar panel at this particular voltage, I mean at 27, it will be possible for us to get the maximum power. And that technique of tracking maximum power point is known as MPPT algorithm. That means the algorithm will help us to extract maximum power from the solar panel is known as MPPT, maximum power point tracking. Is that clear to you?
Yes, sir.
That means the voltage at which PV module can generate maximum power from the solar is known as maximum power point or peak power voltage. And as I have mentioned, that maximum power point depends on the weather condition. I mean the surrounding temperature, cell temperature, as well as the intensity of light, solar irradiation. And MPPT or maximum power point tracking is algorithm that included in charge controllers used for extracting maximum available power from the photovoltaic module under certain conditions. That means we have to apply this algorithm. Otherwise, it might not be possible for us to extract the maximum power from the solar panels. Okay, does this make sense to you? Is that clear to all of you?
Sir,
Yes.
sir, when we increase our power, maximum power, then we will apply the MPP, sir.
Yes, Akhtar Parvez, again.
Sir, when we apply sir, MPPT, that you said that, sir, when we extra means, sir, increase power, sir.
Yes, we will get maximum power from the solar panel. Suppose we know that if it is possible for us to track that maximum power point.
Sir, you said, sir, it is vary from, sir, different situations.
Yes. It depends on the weather condition. So we have to track that point frequently.
If weather is bad, at that time I will extract it, apply MPPT.
Yes, if the weather condition changes, the maximum power point will also change.
Yes, sir.
Okay, and you can see that from the curve. Let's think that the irradiance rate is 1000 watt per meter square. What will be the maximum power that we can get from the solar panel? 225 watts.
Yes.
Yes, sir, 220.
Okay, let's think that the irradiance rate is different. 700 watt per meter square. What will be the maximum power?
Sir,
150.
150 watt. So I think, the maximum power will be changed. In case of 1000 watt per meter square, the maximum power is 225 watt. But if the irradiance rate is different, I mean 700 watt, we will get only 150 watt. So depending on the weather condition, the maximum power that we can achieve, we can get, or we can extract from the solar panel will vary. That's why I'm telling you that we need to apply special technique to track this maximum power. Suppose if we operate the solar panel, suppose the irradiance rate is 700 watt per meter square. The maximum power that we will get from the solar panel is 150 watt. If we operate the solar panel at this particular voltage, 27 voltage, for example, but if we operate the solar panel at different voltage, suppose at this condition, and let's think that that voltage is 29 volt, or if we operate at 25 volt, at 25 volt, what will be the power that we can get from the solar panel?
So
Okay,
this one is temperature, sir. When the temperature is high, sir.
Okay, which curve I am explaining? Which
Sir,
side
first
curve?
one, sir.
The first one. In case of first one, the temperature is constant.
Okay.
Okay.
Second one, sir, is
If we take two variables, then it will be difficult for us, right? Let's think that one variable is constant. I mean, the temperature is constant and only the intensity of light changes.
yes, sir.
Okay. If we take two variables, okay. In that case also we can get. We also need to track the maximum power point. Explaining that if we operate the solar panels at different voltage, we won't get the maximum power.
Yes, sir.
The solar power panel is capable of generating the maximum power. I mean the 700 watt at 25 degrees Celsius and at 700 watt per meter square. Even though it can generate 700 watt per meter square, it can generate 150 watt at this particular condition. If we operate the solar panel at different voltage other than the voltage at which solar panel can generate maximum power, we will get less power from the solar panel. That means if we operate the solar panel at 25 volt, we will get this amount of power. And what is that power? Okay, let's think that this is 130 watt. So we will get 20 watt less from the solar panel. Is that clear to all of you why I am talking that much about this maximum power point?
Yes, sir.
Anyone have any questions regarding this? Then okay, I will try to explain it again. Otherwise, I move to another slide.
Sir, we understand the maximum power, sir.
Okay. So yes, that means okay. Let's think that okay, we have a like this one. What is this one?
Cell, sir.
Okay, let's
Battery.
think that okay.
Sir,
Okay.
it's a battery,
And-
sir.
Okay, battery, and we have solar panels. Okay, we have, okay, let's consider only single panel. Okay, and we are going to charge the battery directly from the solar panels. Okay, so what will have? What will be the operating voltage of this solar panel?
12 volt or
Okay.
24
Okay.
volt.
Let's think that. Okay. Let's think that the battery, the voltage of the battery is 12 volt. Okay. So we need, and if we want to charge the battery, what will be the voltage?
12 volt.
The voltage should be higher. It's this one than the back. Okay.
14, sir.
Okay. Let's think that for 40 or 12.5 it will work. So what's the operating voltage of this solar panel?
Sir, 200.
Why 200? What is the voltage at which the solar panel is working?
12 volts, sir.
Okay, 12 volt. Okay, let's think that is 12 volt or slightly higher than 12 volt. So if we operate the solar panel at 12 volt, and let's think that, okay, this is 12 volt. Okay. So how much power we will get from this for this particular condition, 700 watt per meter square?
It's 80, sir.
Okay, 80, right? But what's the maximum power that the solar panel can generate?
So that is, sir, 100
50.
thousand.
150 for 700 watt per meter square, right? For
Yes, sir.
700, okay, if the irradiance rate is 700 watt per meter square, it's possible to get maximum 150 watt, but at 12 volt, how much power we'll get from the solar panel?
Sir, 80.
Only 80 watts. So how much power we are getting less?
So 150
70.
minus 80.
70.
70 watt. That's why I am trying to explain that we need to operate the solar panel at maximum power point to extract maximum power from the solar cell. Otherwise,
Yes, sir.
we will get less power from the solar panels. Does that make sense to all of you? Is that clear to all of you?
Sir.
Okay.
এবার
So,
বুঝছি স্যার ঠিক মতো স্যার।
okay. So what we have to do here actually, if we want to, okay, I'm going to show a circuit with which we can extract.
বলে কি স্যার সোলার প্যানেল স্যার বাড়াতে হবে স্যার সিরিজে স্যার।
Yes, yeah, that is different thing. Yeah, if we want to increase the voltage or increase the power, right? We need to connect the solar panels in series as well as in
Sir, we need to increase
parallel.
solar
This
cell.
time, yes, we need to increase the solar cells if we want to get more power from the solar panel. Because
Yes,
we are, in this case, we are getting maximum 225 watt. Suppose we want to get 1000 watt from the solar panel. So what we have to do? Okay, we have to either connect the solar in series or as well as in parallel. Okay, that is the thing. And now, okay, I'm going to explain you the circuit to extract the maximum power from the solar panels. Suppose this. Suppose we have solar panels here, and what we will do, we'll use a okay. That means we will not connect the solar panel directly to the load. It will be like this one. Suppose one kind of converter. Have you heard the term DC-DC converter?
Yes, sir.
No.
DC-DC converter, and here is the controller.
DC DC converter or AC DC sir? AC to DC or DC to AC sir?
DC DC converter means it converts DC to another DC.
Okay, sir.
Okay, because the load is DC, right? So
yes, sir.
Okay. So this is the solar panels. Solar. That means we will get the voltage and current information. We will sense the voltage and current of the solar panel. And we will send that information to the controller. The controller will decide at which voltages DC-DC converter needs to be operated so that we can get maximum power, or we can extract maximum power from the solar panels. This
Sir,
is the power. Yes.
DC-DC converter is an amplifier like that.
Actually, DC-DC converter is okay. Simply we can say it's a DC transformer in the sense that in case of AC transformer, step up or step down the voltages, right? AC voltages.
Yes, sir.
In case of DC-DC converter, we can either step up or step down the DC voltages. That
Yes,
means output voltages can be higher than the input voltage, or it can be lower than the input voltages. Clear to all of you? Okay.
yes, sir.
Okay. So this is the input power we are receiving from the solar panel in the DC-DC converter, and let's think that this is output power. What we will do here is that initially in the previous diagram, the solar panel was directly connected to the load. And you have seen that if we directly connect the load with the solar panel, what we can is less power from the solar panel. It's not possible for us to extract the maximum power from the solar panel. And to extract maximum power from the solar panel, what we are doing here, we are using a DC-DC converter as well as a controller, so that we can get maximum power from the solar panel. That means what we are doing here, we will sense the voltage and current of the solar panel. Sorry, and we change the voltage level until we get the maximum power from the solar panel. And this is the basic operating principle or maximum power point tracking. That means, what is our graph? The curve was like this one, right? Okay. Okay, let's think that the curve is like this one. This is power, and this is maximum voltage, right? We know that we will achieve maximum point. The power is maximum at this point. So we don't know exactly at which operating voltage we will get maximum power. So we will try to vary the voltage, and we will measure the power, because we are sensing the voltage and current. This is the voltage and current information we are measuring with the help of voltage sensor and current sensor. We will measure the voltage, how much power, how much voltage we can get from the solar panel, and we will change the voltage level. Suppose the load is operating at a particular voltage, at this voltage. And from the curve, we can easily say that we cannot get maximum power. So we will try to increase the voltage. We will increase this operating voltage. We will change the voltage. That means if we change the voltage, and if we take the data here, and if we measure the power, we can see that the power is increasing, right?
স্যার এই ডেটাটা কি স্যার কন্ট্রোলার করতেছে স্যার?
Point. Yes, the controller will do that. And the next time we will change the voltage again. And if we see that the power is increasing, we will keep the voltage increasing. We will increase.
লোডের উপরে ডিপেন্ড করে স্যার।
What do you mean? এটা কি লোডের উপর ডিপেন্ড করে? কি
স্যার এটা কখন মানে আমরা কখন ভোল্টেজটা ইনক্রিজ করব স্যার? when sir?
Okay. Until we get the maximum power from the solar panel.
Okay, sir.
Actually, we need to track this point. We need to check. Suppose the solar panel was operating at this voltage. We can see that, and we will increase the voltage further. We will either increase or we will decrease. If we increase the voltage, also increasing. If we increase the voltage further, we will see that we will receive this part. And if we increase the voltage further, what will happen? If we increase the voltage further, the power will increase or decrease?
Decreases, sir.
Okay, decreases. So we will consider this point at this, we'll consider this point at the maximum power point. So we will try to operate
The maximum
at,
power.
yes, we will try to operate the solar panels at this point, at this voltage. Then it will extract, or it will generate maximum power from the solar panel.
Yes, sir.
Okay. So for that purpose, we will be using this one.
Sir, but yeah, when
Okay.
okay, sir.
Yes.
Because
Okay.
is there need device which is
Yes. Any question about the solar panels? Okay. If I ask you to draw the block diagram only, will it be difficult for you? What you have to do, you just have to mention the 4 blocks we have here: the solar panel, DC-DC converter, and the load and MPPT controller, and how they are connected. This is the input power,
Sir,
and this is
here, sir, MPPT controller and DC-DC converter are not connected, sir. But yeah, you shown in the figure, sir. You drawn it. You connected, sir.
okay. Let me show you. Okay, it's connected, right?
Yes, sir. Yes, sir. But in
In
the
this
slide
case
figure,
also, it's
it is
also
not
connected,
connected.
right? The same. It's connected.
Okay, sir.
The connection is there. Okay, it's like this one. Okay, and actually, and there are many methods, but okay, I'm not going to cover. Actually, one of the most widely used method for MPPT controller is like this one, perturb and observe method. Actually, as I have mentioned already, that our objective is to track the maximum power point by varying the voltage, operating voltage. Because if we can vary the voltage, then it will be possible for us to track that maximum point. And if we can track that maximum power point for a particular weather condition, we can operate the uh, MPPT controller at that particular point. And by that, it will be possible for us to track the maximum power point. Actually, the method is simply is like this one. It will be easier for you to understand, but okay. But for examination, we can skip this one actually. What we will do here is like this one. We will measure the voltage and the current of the solar panel. Like suppose we have a solar panel. Okay, and suppose this is the voltage VPV that is across the solar panel, and IPV is the current. That we are getting from the solar panel. So if we know the current and the voltage, maximum power, sorry, we will get the power, right? Because power is the product of current and
Yes, sir.
voltage. If the current that we are receiving from the solar panel is IPV and the voltage across the solar panel is VPV, then the power will be the product of this current and voltage. And we will check whether this power is higher than the previous voltage or not. Can you see the difference here, delta PV?
Yeah.
Delta, okay, delta PV. The difference of power uh, at this time and the previous time. So we will check whether the power is increasing or not. If the power is increasing, that means if the difference of power, the power that we get at this point and we have received at the previous condition is increasing, then we will come here and we will check whether the voltage is increasing or decreasing. If the voltage is increasing, then we will increase the voltage again. If the power is increasing but the voltage is decreasing, then what we will do? We will decrease the voltage, further decrease the voltage. Why it is like this one? Actually, it will be like this one. Suppose this one. Let's think that the maximum power point is here. And the if the solar power is operating at this point, and if the power is increasing, then what we have to do? The power is increasing and voltage is also increasing. What does that mean? That means power is increasing means the maximum power will be in the right direction. Then to track this point, we have to increase the voltage. But if we are at this point, and the voltage and power is increasing, what does that mean? That means that the maximum power point will be in the left direction. So in that case, we have to decrease the voltage. But if we are at this point and the maximum power point is here, we have to increase the voltage to get the maximum power. Or if we are here at this point and power is increasing, but the voltage is decreasing, then the maximum power point will be here. That means we have to move backward. That means this is the MPPT algorithm. If we follow this algorithm, that means actually then it will be possible for us to track the maximum power from the solar panel. Is it clear to all of you, or you are having difficulties to understand this concept? Okay, any questions from this one, or you want me to explain it more in more details so that you can have a better understanding?
Sir, I think
Okay.
it's okay, sir.
Okay. Then we can proceed to the next slide.
Sir, can you give us
Yes.
the date of exam, sir?
Okay, date of exam.
Yes,
Okay,
sir.
actually we're not sure yet whether the exam will be online or offline. Okay, in
Sir,
case
most
of
probably it will be online because, sir, the corona increasing rate is, sir, more than, sir, 35%.
I think not 35, 31. It was 31% yesterday. Okay,
Sir,
it's more than
last day, sir, it was 32%, sir.
30.
2.
Okay, 32%.
32
Okay,
to 33.
okay. It was more than 30%. Okay, no problem. So, okay, do you want to appear in the exam on Saturday or on Wednesday? Because this
Sir,
time
in the
we also
class
have
time, sir.
this time we also have Viva.
So class time
Yes,
will be better, I think, sir.
Okay,
Class
then
time
okay.
will be better, sir.
Okay, in that case, okay, the exam will be on Wednesday.
Sir, Wednesday, 9th
Written
of
exam,
January,
yes,
sir.
yes, written exam will be on Wednesday, and okay, yes, the exam will start from 5th February, the midterm exam.
Sir, it's first.
Sorry, the first term exam. Okay, sorry for that. So midterm exam, sorry, first
When
term
it is
exam.
9, sir?
Saturday, Sunday, Monday, Tuesday, Wednesday. Yes.
Wednesday is 9, sir. 9, sir.
Okay, 9. The written exam will be on the 9th February and Viva will be on 10th because we have another class on 10th, right?
Yes, sir.
Yes, sir.
Okay, the Viva will be on
Sir,
10.
can you give us the schedule of the Viva, or sir, we have to
Okay,
do it
yeah, yes,
randomly, sir?
yes. Okay, I will do that, and I will do that. Okay, I think we are yet to know whether the exam will definitely start on 5th or not. Okay, after getting the exam schedule, okay, definitely I will be uh, uploading the schedule of Viva in the Google Classroom.
Okay, sir.
Okay, okay, no problem. So the exam will be on 9th. It's final.
Okay, sir.
Okay, sir.
Okay. And actually, though we have talked about much about solar photovoltaic and how we can extract maximum powers from the solar panels, we are yet to know the equivalent circuit of a solar cell. Actually, the ideal model of a solar cell is like this one. Suppose, actually, ideal model, that's the difference between the ideal model and the exact model. Suppose this one is the photocurrent, the current that we are receiving from the solar cell. Actually, there is a PN junction, that means a diode, and it will be connected like this one. So some amount of current will be flowing through that diode. And this is the amount of current that we will be receiving from the solar panel or solar cell to the load. This is the cell current. That means if we connect a load here, okay, let's think that. And IPH is the photocurrent that the solar cell will be generating, and some amount of current will flow internally, and we can consider equivalent as a diode. Okay, let's think that the current that will be flowing through the diode is ID. So what will be the current that we will get
Sir,
from the
why did
solar
you
cell?
give here transformer symbol?
Sorry,
Sir, isn't it a transformer symbol?
which one?
Yes, sir, this
Okay,
one.
okay, this one. Okay. The for photocurrent also we also use this symbol actually. And for transformer we use different symbol, right?
Sir, it's for simulation app, this symbol, transformer.
Okay. For simulation, which simulator circuit are you using?
Sir, actually, sir, when I used Simulink MATLAB, that time I have used
Okay.
this kind of symbol.
Okay. This is the case of ideal transformer, right? Symbol of ideal transformer. Okay. Anyway, so what will be the cell current that we'll be receiving from the solar panel?
Sir, can you explain it again, sir?
Okay, that is okay. pH is the IPH is the photocurrent that the solar cell is generating, and ID is the current, diode current that is flowing internally in the PN junction of the solar cell, and I cell is the current that we are receiving from the solar cell. So it will be like this one. I cell will be IPH. Okay, let's consider this node actually. So what will be the current? Incoming current and outgoing current. The current that is coming to this node is IPH, right? So we can
Yes.
consider I cell equals IPH minus ID. This is the ideal model of a solar cell. Ideal. Equivalent circuit. And it will look like this one. Let's think that we are getting constant current from the solar panel. Suppose okay. Let's think that this is the photocurrent. This is IPH. And this one is the I cell current. Actually, we know this shape already, right? If we draw the voltage curve. And let's think that okay, the diode current will be like this one. Okay, is it clear?
Yes, sir.
And this one is the diode current. Okay.
So cell current will be decrease, diode current will be increase.
Okay, so the total current is the same actually, right? IPH, I mean the photocurrent is the summation of cell current and diode current. So it's constantly generating this, and you know the property of the diode, right? So this will be the shapes of the current at different sections, and this is for ideal equivalent circuit. But in practical cases,